building code. I just present this as something for local communities to think about. Keep the bulldozer out of the creek. I've been dismayed after the recent flooding in the Mohawk Valley the past few weeks of seeing pictures in my local paper of bulldozers in the creek. Scott can talk to you about that one. But notice how I passed the baton. In general, if you straighten a stream, if you clear out a stream, what you're going to do is you're going to force that stream to have more energy. It's going to move faster, and when it moves faster, the first bend that it finds, it's going to want to do something with that bend. Also, streams carry a lot more than water. Streams carry a base load of debris, gravel, rocks, depending on what it is. And people will look at that stream and say, hey, there's a gravel bed. That's got to be getting in the way of the water. But if you look at the cross-section of the stream, every stream reaches equilibrium. And if you look at a stream, say, with a gravel bed, you'll probably find that right next to the gravel bed, there's a channel that's deeper than the part of the stream that doesn't have a gravel bed. So it means that the stream might be a very healthy stream that's doing what it wants to do and doing it efficiently. Also, after you get a large flood, and I think there's actually been a study done on this where people have kind of marked large rocks that were part of a gravel bed and found after the flood there were still rocks in that gravel bed, but they were different rocks. They weren't the same rocks. Those rocks moved downstream or replaced by other rocks. So without sort of a scientific approach to stream management, I know that after a flood there's a tendency we need to get the stuff out of there, and certainly there is material that you do need to get out if you're potentially blocking a bridge, blocking a culvert, causing a clear and present danger. But a lot of the work that's done in the stream is with heavy equipment is counterproductive. It makes the threat higher rather than lower. The other thing that you want to avoid is taking material out of the stream and leaving it on the stream bank. And what you do when that happens is you leave an unconsolidated berm. Two things happen with these unconsolidated, well, three things happen. One is that you kill the streamside vegetation, which makes the stream bank even more prone to erosion. Second is that you're creating an impediment to the flow of water that wants to spread onto the floodplain, which is going to force the water higher. By forcing it higher, you're making it go faster, you're making it even more dangerous, more erosive, and because it tends to be an unconsolidated, unengineered berm, at some point that berm is going to blow out and you're going to have catastrophic damage in that location rather than the damage that's caused when the water gradually comes up. And call DEC with questions, whether it's questions about the floodplain permit requirements, in which case you can call our New Paltz office, talk to Mark Lewis, or you can call my office up in Albany, or with stream permit questions, then the New Paltz office would handle that. So let's talk a little bit about risk, figure out where I am here. What this chart tries to do is it looks at, and it's kind of what I showed you before, but some people see it on a chart a little better. This is the flood probability of a 100-year event, of a 1% flood over a 30-year period. So what we're saying here is that the 100-year flood has a 26% probability over 30 years, and these are floods of different magnitudes. So the 500-year flood is a 6% probability.